Hey, good morning, everyone. How are you doing today?
Doing good.
I'm good. Sorry about the delay. Okay, so where are we at? We last time we're finishing up things with functions, right? And I had given you this graph here and then also asked you to do some problems off of these pages. So were there any questions on this?
Yes, I had a question on number 5 from page 85.
Okay, page 85, number 5. Let me grab it real quick. Okay. So here was number 5 from page 85, and they were asking you to use this function right here. Is that right?
Yes.
Okay, I just want to make sure I'm doing the right problem here. So you're asked to find what is f of 1/8, and you're given this function 4x plus 7. So all you're going to do is replace the x with 1/8. So that would become 4 times the 1/8, and then plus 7. And then you can look at that as 4 over 1, and then just multiply straight across. So you get 4 over 8 plus 7. Did you get that part, or did you reduce that
Yeah,
fraction?
that was where I got in there, and I think that's where I messed up.
Okay, so here all you have to do, you can reduce the fraction since 4 goes into 4 once and 4 goes into 8 twice. You can turn it into 1/2 plus 7. And then from there, you put those two together, but you need a common denominator. So we just rewrite the 7 as 7 over 1. And then you can just do that little cross thing that we learned back in the beginning. So you'll get 1, and then you'll add to that 14, and you'll put that over 2 times 1. So you get 15 over 2.
Okay, that's where I messed up the crossing. Yeah.
Okay.
Yeah.
You could have done it when you had 4 over 8 plus 7. You could have done that same thing where you do 4 here plus 8 times 7 is 56, and then over 8 times 1, which is 8. The only problem with this is if you add that together, you get 60 over 8. That fraction can be reduced. So 4 goes into both of those. 4 goes into that 15 times. 4 goes into that twice. So you wind up at the same place.
So for these questions, do you want us to give you the answer in a fraction or a decimal?
Fraction would be preferable. If they want you to graph the point, like if they wanted you to actually graph the point, it would be better to be in a decimal,
Okay.
right? But if you're not graphing it, if you're just asked to evaluate it, then we just leave it as a fraction.
Okay.
Okay,
I had a
good.
question.
Yeah, go ahead.
I had a question about the quiz. So when I uploaded it this morning, I uploaded it simply with the answers. I almost drew the graph, but I was a little bit worried about messing up the point
Yeah.
that you have on here when I drew it. Is that okay to just upload the answers?
Yeah. Just the answers are fine.
Okay.
Let's see how many people remember to do that. Let's see here.
I'm still in the process of turning mine in, but I did it.
I did mine yesterday. Did you receive
So
it?
I have quite a few here. That's good. Yeah, some of you did it like the same day, like right after class, just submitted the answers. So that's good. Okay, any other questions over this or over the homework? Okay, we're going to switch gears now. All right, we're still going to be dealing with linear functions, but we're going to start doing some word problems. So don't freak out. Everyone always freaks out when there's word problems. I wanted to start with something that I guess maybe we can relate to a little bit. Let's say I'm trying to think of something that might be something you can somehow relate to. How about Fiesta? We haven't had Fiesta here in San Antonio in a while. not the real like Fiesta. But let's imagine that we're going to go to Fiesta. Okay. Let's say we're going to go to Nyosa, which is an event that happens downtown at night, right? A lot of college students usually go to Nyosa, especially on Thursday nights, or the Thursday night of Nyosa. So let's say we're going to go to Nyosa and we have to buy a ticket, and all we're going to do when we get there is drink beer. Okay, that's it. So we're gonna go to Nyosa and we're gonna drink beer, and that's all we're gonna do. All right. So let's say that the ticket to get in to Nyosa is $20. I don't know how much it is right now, but I'm just making this up. The ticket for Nyosa, night in Old San Antonio, if you're not familiar with what that stands for. Ticket's $20, and beer, oh, I can't imagine how much beer is now. I'm gonna go with like $7, okay, because it's probably pretty expensive. The beer's gotten more expensive and the cups have gotten smaller. All right, so here we go. So what we're gonna try and think about is what would happen. We're gonna make kind of like a tea table, and we're gonna figure out the input is gonna be the number of beers we have. Okay, so this is the input. And then the output is going to be our total cost. All right. So let's think about this. If you go to Nyosa and you have no beers, how much is your total cost going to be to go to Nyosa then?
$20.
$20, right? Because you still have to get in the door, right? So even if you have no beers, you're going to have $20 cost. So what if you have one beer? Well, it'll be 20 plus the 7, right? For the beer. So $27. What if you have 2? Well, the 20 plus 2 times 7, right? 14, because you're going to have 2 beers. So this will be, what is that, 34? If we have 3, 20 plus 3 times 7, this is going to be, what, 41? And so on and so forth, right? So when we have something like this, what we need to do is recognize within this kind of formula that the 20 is always there, right? No matter what, the 20 is always there. So we call this $20 a fixed cost. Because no matter what, no matter how much beer we drink, we're going to have to pay the $20 to get in the door, right? Now, the $7 is what we call the variable cost, because that depends on how many beers we have, right? If we have none, we won't pay anything. If we have 3, we're gonna have to pay $21 for beer, right? So our goal right now is to see if we can come up with a function that represents this relationship, okay? So let me do this first problem, and then as we do it, maybe you'll start to see what's going on here. You know how we've been using this notation, f of x equals, like the problem I was asked about at the beginning of class was 4x plus 7, right? That's the problem from the homework. This notation just means that we have a function that is equal to this equation, right? Notice that in this equation, no matter what x is, 7 is always 7, right? So no matter what I plug in for x, the 7 always stays there. And then this right here, the 4 times x, that value will actually depend on what I plug in for x. And that's very similar to what's happening over here. We have the 20 is always going to stay there. And then the rest of it is always going to be 7 times however many beers we have. So what I'm going to do is I'm going to create this function. I'm going to call it C of x. Now C, I'm using capital C to represent cost. Okay, I could call that function anything I want, but I'm going to use capital C to represent cost. This cost should be 7 times x plus 20. So it is the variable cost And then this is our fixed cost. Hey, I hate to stop real quick. It's such a beautiful day out. I've got my windows open and somebody is burning something and it's starting to stink real bad in here. So just hold on real quick. I'm gonna shut my windows. That's a bummer. Such a pretty day. Okay, sorry about that. All right, so do you all see how we have taken this real world kind of problem and we've converted it into a function, right? A linear function. It looks a lot like this here, looks a lot like mx plus b, right? Which was the formula we used for a line. The m here was always our slope, and the b here was our y-intercept. So for us, this fixed cost is really going to be a y-intercept if we tried to graph this, and the variable cost would represent the slope. Does that make sense? We can graph this cost function. Let's do it. Let's graph it. So if I graph this, let me put a grid here. So if I graph this cost function, I start at the y-intercept, right? That's where I start, which is going to be where? Where's my y-intercept?
20.
Wouldn't it,
20. Okay, so I'm going to count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. Here's 20. Okay, so I put a dot here. And now another point on this line, I would have to use the slope, right? Now the slope is 7, which I look at as 7 over 1. So my rise is 7 and my run is 1, right? So I'm going to go up 7 to the right 1. So going up 7, I'm going to kind of run out of room here. Let me move this down, move it over here. So let me extend this up a little bit. So if I go up 7 from here, remember I'm counting by 2. So that's 22, 24, 26. This is 28 right there because I'm counting by 2s. So I need to go up 7. So 2, 4, 6, 7 would be about right there. And then I go to the right 1, right? Rise 7 over to the right 1. So here's 1 here. Go to the right 1, I put a dot. And now I connect these with a straight line, right? When I draw this though, watch, when I draw this line, it goes like this. I am not going to draw this part of the line. Why?
because we're starting at 20 as the base.
Yeah, so think about the input, right? The input for this function is x, right? What does x represent to us in this problem? What is x?
The beers.
What's the thing that's changing? The number of beers, right? So when I have no beers, we pay 20 bucks. When I have 1 beer, it's going to be 27. When I have 2, right? We did this, be 34. And then 5, 3, it'll be 41 and so on. But you can't have negative beers, right? You can't have negative amount of beer. So we don't want to draw the graph over here, which is important because you know, if I started class today and I said, hey, everyone, graph this line. 20. If I said, hey, everyone, graph that line, you would draw me the whole line, because it's not, I'm not giving you that line in the context of a real world problem. Once I give it to you in the context of a real world problem, then you have to think about what makes sense and what doesn't make sense. Okay, are we good? We understand? So now I have a question for you. Okay, I'm going to ask you a few questions. Still in the same problem. First question is, how much will it cost if you drink 6 beers? And B, is if you spend $83, how many beers did you have? All right. So remember, these questions are now based upon this scenario of this NIOSA problem, and we have the function for it. The function, I'll write it to the side, was C of X equals 7X plus 20, right? The X is the number of beers, right? And what comes out, okay, what comes out is the cost, right? So who wants to tell me how we're going to do part A?
You would plug in 6 for X and then solve the problem that way.
Yeah, so what part A is asking us is to take your cost function and replace the X with 6. So that's just 7 times 6 plus 20. 7 times 6 is 42 plus 20,
62.
$62. So if we drink 6 beers, we would spend $62 to go to NIOSA. Make sense?
Yes, that's not even including the Uber, huh?
Yeah, hopefully you're Ubering
Exactly. Yeah.
or taking the bus. I used to go to NIOSA a lot until I started actually teaching. And then I figured I was always at NIOSA and I would always see my students there. So it was like kind of crazy. So I stopped going on Thursdays. But the whole point of that is we used to catch the bus at Park and Ride, and the bus was like half the fun because they used to let you like drink on the bus. You used to be able to like have beer on the bus, and it was like a party on the bus. It was so awesome. They stopped doing that a long time ago. Okay, now for part B, they're saying if you spend $83, right? They're actually providing us the cost, right? And they're asking us how many beers. Now beers is X, right? So do you remember in the problems from the homework where you had the problem like this? We had 2 basic types of problems. One problem was, hey, plug in a value, plug in, this is the X. These first questions we're asking you, what is the Y value that goes with that X, right? And then G, H, and I, these are the Y values, and you're trying to figure out the X values they come from. Do you all see that this problem that I'm asking you, these 2 problems are like those 2 types of problems? The first one is, hey, plug in 6 for X. Part B is saying, do what? Who can tell me how I'm going to do part B?
Set the equation
79.
equal.
Set the equation. So I'm going to take the equation, 7x plus 20, and do what with it?
Set it equal to 83.
Set it equal to 83. See, Part A and part B are very different, right? Part A, you're just replacing X with 6, just figuring out what the number is. Part B, you're setting the equation equal to 83 and then solving for X. So I'm going to solve for X now by subtracting 20 on both sides. What is that, 63? And then dividing both sides by 7. And 63 divided by 7 is 9. So you probably have had too much to drink, it looks like. I don't know. Niosa starts at 5 or 6, I don't remember. And ends, I believe, at midnight or 11 p.m. I don't know, it depends. Those cups are really small. I think they're all the way down to like 10-ounce cups now. They used to be big old 14-ounce, 16-ounce cups. Okay, so you've had 9 beers, right? Let's put beers here because we need to make sure we understand what that quantity represents. We drink 6 beers, we're going to spend 62 bucks. If we spent 83 bucks, we drank 9 beers. Okay, what do y'all think? Does this example make sense? Any questions on this? We're going to do something different now, a different sort of problem. This is kind of like the basic, like we got the idea. Let's do something else now. We're okay? All right, so some of you are going to transfer out to a different college, right? When you're done at Northwest Vista, probably UTSA, maybe you're going to go some other college. Most students transfer out to UTSA. So I'm going to go look up UTSA's tuition, all right? I want to use some relevant real numbers, okay? So this is tuition. 8262. I'm just going off this website, okay? So, or just what I'm finding on the web. We're not going to get too far into this. Well, maybe we can. Let's see how easy it is to find this tuition and fees. Let's go spring. Let me see. We'll go fall. Oh, here we go. Wow. Okay, I wasn't expecting to find this. This looks like a mess. This, this looks very hard to read.
I want to say it's around $18,000 a year.
A year, yeah.
I think so. Somewhere, it depends on if you live at home or not and things like that, but
Yeah.
it's somewhere between 16 and 18,000. I think it gets close to 18,000 with books.
Yeah. So let's look at it per semester, okay? Per semester. And I don't know if undergraduate, I'm not sure. These are all, when you register, I know it's hard to read, but when you register at a school, you pay a bunch of fees, right? These fees are fees no matter what, okay? Whether you take 1 class or you take 4 classes, everyone's got to pay the same fees, all right? These are like, they do increase, okay? I'm lying a little bit, but you can basically look at it like a fixed cost, kind of like the $20 to get into Niosa, all right? So, yeah, I'm just going to have to make up some numbers here just to make this easy for us. Let's say that tuition at UTSA is, again, I'm making this up, okay? Don't be telling people, oh, my teacher told me this. Okay, I'm just making this up. I think this will be conservative, okay? Meaning it's probably more expensive than this. Is $62.50 for fees, right? And $324 per credit hour. That's it. That's all I'm going to give you. So the tuition at UTSA, and this is per semester. Okay, the tuition at UTSA per semester is $62.50 in fees and then $325 per credit hour. Do you all know what a credit hour is? When you take, what is the name of this class? Or this is math what? Do y'all know? Math
13, 14.
13, 14. Okay, do y'all know what these numbers stand for? Y'all know what the 1 stands for?
Doesn't that mean like
Yes, you
first
get
year?
3 credit hours.
First year. This 1 means it's like a first year course. So this is like, usually college is broken up into first year, second year, third year, fourth year, almost like freshman, sophomore, junior, senior, right? So the 1 stands for, it's a first year course. The 3 is the credit hours. Okay. And then the 14 is just a number that we get to play with. These 2 numbers kind of like you can distinguish between different math classes. So there's another class called 1324, which is a completely different class. It's not college algebra. There's 1325, that's a business, a math class. So the last 2 numbers don't really matter. The first 2 numbers are what matter. That tells you what level you're at and how many credit hours, okay? So by taking this class, if you took this class at UTSA, this would be 3 credit hours. So you're gonna have to do $324 times 3. Make sense? Yes? Okay, so I would like for you, part A, or let's give a situation here. You plan to take these courses. Oops. Let's say you're going to take math 13, 14. You're going to take math, or no, not math. Let's do another one. How about chemistry? I don't even know, 1301. How about biology? 1402. And then you're going to throw into that some like fun class. Okay, so maybe you're going to take like some art class that's going to be a 1205. Maybe that's, just that class that you learn how to, like, I don't know, weave baskets or something. Right? That's what you plan on taking. Here's what I'd like for you to determine. First, find a cost function which gives the cost as a function of credit hours taken. B, how much will you pay if you take those classes? And then C, if next semester you have a max budget of, let's say, $7,500, how many credit hours can you take? Okay, so I'm going to run through these again, and then I'm going to break y'all out into groups, and I'm going to let y'all work on this. Okay, but I just want to kind of run through this one more time. We're talking about going to UTSA. The cost is $62.50 for fees, and then $324 for each credit hour you take. You plan to take these courses, all right? Now, the first thing that's being asked is for you to find a cost function which gives the cost as a function of credit hours. My hint to you on this is that basically you need to come up with that thing, cost C of X, which equals what? For like in general, not for you specifically, but for anyone going to UTSA, what would that cost function look like? Then for part B, I want to know exactly for you, okay, with this scenario, how much is that going to cost you? Right? And then for part C, you're thinking about next semester and you already know that you only have this much money to spend, right? Can you tell me how many credit hours you can possibly take then, if that's the only money you have? Is this making sense? Kind of? I hope in groups y'all can, kind of hash through this. So I'll give everyone more time if you need to. If you need to take a picture of the screen, you can, whatever. But I'm going to put you in breakout rooms now. And let's just take, I don't know, 10 minutes. See how far you can get with this in 10 minutes. In the breakout rooms, there's going to be, I'm going to go 3 to 4 people in each breakout room. So please talk to one another, verify each other's answers. Like, are you getting this? Okay, yeah, I'm getting that. You don't understand something, ask each other. See how this goes. So you should be invited to a breakout room as soon as you kind of copy things down or taking pictures. Go ahead and join the room and have fun. right, everyone, we're just waiting for everyone to get back in here. Michaela, are you on campus?
Yes, sir.
Yeah. Okay. What building is that? I don't recognize it. Where are you near?
Live Oak.
Live Oak? Okay.
I'm like over by the lake.
Mm-hmm.
Yeah.
Okay, now I know. Now I recognize where you are. Okay. It's a nice day to be out there.
It's really pretty out here. It was freezing this morning, but
It was cold. I was there getting
it
COVID
feels
test.
really good now.
All right, I think everyone's here. Let's just let everyone join in. Okay, so I will take volunteer. I went and jumped into a few of the groups, and by the time I did that, most of y'all were done. So which group would like to volunteer part A? Whoa.
We can do it, I guess.
Okay, what do you got?
So for part A, let me see. So, if my understanding is correct, so part A would be trying to find out what the total cost was if you took those classes, right?
That's part B. Part
Oh.
A is just a general formula for the cost, regardless of how many classes you take.
So, the general formula, I believe, would be f of x equals 324x plus 6,250.
Yes, that would be correct. Now I'm going to call it C of X. If you called it F of X, that's fine. I'm calling it C of X. just
Okay, yeah.
the cost, but that's really not that important. Okay, good. That would be your cost function. Now remember, that is not representing how much you would spend if you take the courses you plan to spend. This is just the cost function in general for anybody taking classes at UTSA for that semester. All right. Okay, good. How about part B? Who wants to give me part B?
I can do part B.
Okay, what do you got, Joshua?
So in total, the if you did the classes and the 6,250, it would be 10,138. But if it
Okay,
was just
so-
the classes themselves, then it would only be $3,888.
Okay, so how many credit hours do you
There's
plan
12
on
credit
taking?
hours because
12.
3, 3, 4, 2. So
3, 3, 4, 2. So you add those up, you get 12. So you plan on taking 12 credit hours. So that
Totally
means,
missed that step.
12
sorry?
times.
Our group totally missed that step. We just thought like, oh, it's 4 classes.
yeah, it's always based on the credit hours. So
Yeah,
if you
so
take
that's
a
why it would
4-hour
be
credit,
12 times the 324.
yeah. So what I'd like for you to see is that once we have the cost function, right? Part B is asking you to plug 12 into that function. That's all at once, right? Which you did. You did 324 times 12 plus 6250. And what did you say that was? 10,000 what?
It was 10,138.
Okay, that sounds right. Everyone agree? Everyone understand? And I put the $ in front of that because it actually represents the cost, right? It's the money we're going to have to spend. So I put $ in front. All right, who got C? C is the hardest one, I think.
I got with a max budget of 7,500, you'd be able to take 3 credit hours with $276 left over.
So how did you do that? How did you set up C?
So I set up the equation equal to 7,500. Then I subtracted 6,250 from both sides, then divided by 324.
Good. So when you subtract 6,250, you get what?
1,250.
Does everyone understand? Again, this is like the previous problem with the beer, right? One of the first, like part B on this problem is like me telling you how much does it cost to drink 6 beers. Part B is saying how much does it cost you to take 12 credit hours. On the second part of the previous problem, I said, oh, well, if you spend $83, how many beers did you drink? Here, same sort of idea. if we only have a budget of $7,500, how many credit hours can we take? So we set the equation equal to the cost, the money we have. All right, you divide it by 324, and what did you get for X? It should be, you can do this on a calculator if you want.
I didn't do it on a calculator, so I just got 3 with a remainder of 276.
Okay, so you do 1250 divided by 324, which I think you probably did the old school, like long division like this.
Yeah.
Okay, which is fine. I'm just gonna do it on my calculator, and this is gonna be approximately 3.85 or 86, let's say. So looking at this answer, you can't quite take 4 credit hours with that budget. You need a little more money to be able to do 4 credit hours. So the most you can take is 3 credit hours. Make sense? So your answer would be 3 credit hours, which is usually, I mean, that's kind of like 1 class, isn't it? Most classes are 3 credit hours. Some are 4, but most are 3. The standard is 3. Okay. Does that all kind of make sense? Any questions on this? I want to take a look at a couple of problems from the, not the homework. I'm going to do some problems off of here. Let me see which ones I want to do. Now, this one is a tricky one. This one causes students issues. All right, let's read through this first. Joe has a part-time job caring for and walking dogs. So I guess people, while they're at work, they need their dogs taken care of, or maybe if they go out of town. So they pay someone to come to their house and walk their dogs. This happens a lot in big cities where you don't have a lot of open areas and backyards. People live in apartments and condos, so they have to pay people to come walk their dogs. All right, he estimates that his annual means yearly, annual insurance is $420. So with this job, Joe has to have insurance in case he's walking the dog and it, gets off the leash and gets run over by a car and the person sues Joe, right? He has to have insurance to cover in case something bad happens, right? So he's got to pay $420 a year out of his pocket just to run his business. Make sense? On average, he spends $4.50 on gasoline every time he goes and does a job, on average. He has to drive there, drive home. That costs him $4.50 in gas. He charges $15 per visit. So he's charging every job he does. That's pretty cheap. $15 to come take their dog. All right, so explain how first we will find this total cost function. What we're trying to do is come up with a cost function for Joe. Cost. How much is it going to cost him to run his business? Now, don't confuse this with how much is he going to make. All right, we're looking at a function that will represent how much it will cost him, right? How much it will cost him.
Do you have to include the 450 every time, or can you just take that out of the 15?
Yeah, okay, so let's talk about that. But so if he does one job, okay, if he does no jobs, do we have a fixed cost?
He doesn't have to spend any money, so technically it would still be like 1150.
No, I'm saying if he
Finding
doesn't
the
do any
total
jobs.
cost.
Oh,
and he
that
does
would be
no
the
jobs.
420.
Yeah,
It'd
because
be
he
zero.
still has to pay for the insurance.
Yeah, he still has to have himself covered, the insurance, right? So for sure, the 420 is going to come out of pocket. So I'm going to put 420 here at the end. And I'm putting plus. Now we could talk about this, but this is a cost function. It is going to give us a number that represents the cost. We know right now that the cost, no matter what, is $420, right? I'm not going to put negative 420. I'm going to count that 420 as a positive, even though we know it's a cost, so it's coming out of his pocket, right?
Yeah.
Okay. Now, that's regardless of how many dogs he walks, right? Or how many jobs he does. Now let's talk about each job. Okay. Each job he does, how much money is going out and how much money is coming in. So if he does one job, right? Let's say he does, let's do it over here. Let's do a T-table. This might help us.
So like if he does one job, he gets paid $15, but he loses $450.
Okay, so number of jobs, and then this is going to be the cost. So if he does no jobs, 420, hold on. If he does one job, what did you say it would be? It's 420, right?
Technically 1150.
So that you're getting 1150 from saying $15, right? Is how much he's going to earn, but he's got to put out how much in gas? 450, right? So that's where you're getting the 1150 from. Does everyone understand that? Okay. So is this correct to put 1150 here?
So technically it would be like 1150x.
No,
And activated visit.
because
Maybe. Is 1150 correct?
no, not for the equation that we're setting up here.
How,
Because
okay,
it
so how do you mean?
Because we're not finding how much money he's making from it. We're only finding the costs.
That's right.
So instead we would use 450 because every visit is costing him 450.
That's right. So the reason why I'm showing this problem, because it's tricky, because everyone wants to use the $15 for something, right? Because they're trying to say, oh, well, he's making $15. He has to spend 450. This function that we're talking about is only the cost, only the cost. Okay, we're not taking into account at all the money coming in. That's a different function. Okay, we call that a revenue function. That's a different topic. So we are just interested in the cost. So if he does this many jobs, no jobs, he has to have insurance. If he does one job, he's going to have to pay 420 plus 450 for the gas. Joshua, do you see what I'm saying? We're ignoring.
Oh, no, yeah, I totally get it. It just the wording that got me caught up.
Yeah, that's why I want to make sure that we're clear on the wording, because if you're only asked for cost,
you only use the cost.
Pardon?
So even with C, you'd only like take the cost into as variables.
That's right. You're only looking at the money going out of his pocket, right? The money going out. So here's what we would have. 450. Now this is a variable cost because this depends on the number of jobs he has. So 450x and then plus the 420. So again, strictly in terms of cost for Joe, this is his cost function. If he does no jobs, it's 420. If he does one job, it's 420 plus the gas, right? If he does two jobs, it's 420 plus the gas twice. 3 jobs, 420 plus the gas 3 times, right? And this just gives us cost. Got it?
Yeah.
Okay. Now, it asks us to fill in a table that's on the previous page. Here we go. Copy that. Let me bring it over here. So they want us to fill out this table, and we have our cost function there. So if we do 0 visits, how much will it cost? Everyone?
420.
420.
20, okay. If we do 1 visit, we'll just plug 1 in here, right? So it'll be 420 plus
Plus 450.
$4.50. So what's that? 420, 450, right? And then if we add 450 again, so at 429. You could fill out the rest, yes?
So for C, It would just be like 1,000 minus 420, and then the rest divided by the 450.
Yeah, so for C, right, it's saying suppose his budget is $1,000. How much could he make? How much, if he has that in his pocket, how many visits can he make? Look, we're not taking into account the money he's bringing in. So I understand that this doesn't seem relevant. Like, why would you only look at the cost? That doesn't make a lot of sense, but you'll see, I'm going to add to this after we're done. So suppose his budget is $1,000. How many visits could he do? So yeah, I think it was Joshua who said that. What we'll do is we'll take 450x plus 420, and we'll set it equal to 1,000. This is for part C. And then we subtract 420 on both sides, and that should give us 580. And then we take 580 and divide that by 450. Oops. I'm getting X is approximately 128.89. Anyone else get that?
That's what I got.
Yeah. Okay. So that means in terms of number of visits he can do, 128. Okay. Now, the problem does not talk anymore about this. We're done, okay? But now I'm going to introduce you to what's called, this is the cost function. I want to talk about what's called the revenue function. The revenue function is basically the money coming in, okay? The money coming in, and you ignore the cost, okay? Ignore the cost completely. So what would his revenue function be? I'm gonna write it down here. I'll write it so I can fit it on this page. I'm gonna put it right over here. I'm gonna call it R of X, R for revenue. What will it be? So what
Would it be
is
the $11?
What's that?
Would it be the $11.50?
So ignore the cost. We realize that the
Right,
gas is going to
that's
cost.
right.
Just ignore the cost. How much money does he bring in? So how much is he charging per visit?
15.
15, right? And he's going to get 15 for each visit he does, right? So if he does no visits, he makes no money. If he makes one visit, $15, 2 visits, $30, right? 3 visits, 45. So shouldn't it just be 15x?
Mhm.
Right? That's his revenue function. Y'all good? Revenue is just the money coming in. That's all it is. Ignore the cost. Now, the most important function, which is called the profit function. The profit function is always equal to the revenue minus the cost. That's how you can determine how much money you make in this business. So we know the revenue function, don't we? 15x. We know the cost function. We wrote it down right here. So the profit function, I'm going to call it capital P of X, will be the revenue function, 15x. Take away the cost function. Now, very important, you're taking away the whole cost function. So you have to subtract both of them. Right, see how you're subtracting the cost? Since there's 2 terms, you have to have it in parentheses. So the minus will go through to both. And now this right here becomes 15x minus 4.5x minus 420, which you can put these two together. That's the 1150. We finally have gotten to the 1150. That's his profit function. So this is not a business math class, okay? This is college algebra. We're just working with functions. I am showing you a little bit more than what the packet shows you. The packet talks about the cost function, but I think we're kind of like stopping too early. We should talk about cost and revenue and profit, not just one of them, because it's better to see them all together, because this is the way it works in business. You look at what are all your costs, right? Figure out that function. You figure out where's the money coming in, right? Figure out that function, and then you subtract, and that gives you how much money you're going to end up with at the end of the day, your profit, the money that you'll be able to put into the bank. All right, so look at this profit function, right? I'm going to ask you a question now. You ready? A, how many jobs for Joe to break even? So what do I mean by break even?
Have to cross the point where you aren't losing money
Or
from
gaining,
doing
right?
it, or gaining.
So this is the break-even point. Is basically, we know that if he does no jobs, right? No jobs, he still has to pay for the insurance, right? 420. So he needs to do some jobs, or it's not even worth having the business at all. So the break-even point is the number of jobs that are required that he's not actually losing money. So what does that mean? If this is his, if this in blue is his total profit, the break-even point corresponds to asking when that profit is equal to what? We don't want to lose money. We don't want to gain. Dorley?
420.
No. Profit is like at the end of the day, when everything's paid for and he's brought in the money, how much money does he have in his pocket, right? If we don't want him to lose money, but we also don't want him to gain money, then we need his profit to be what?
Would it be 420?
Not 420,
Oh,
because that would mean he gained $420.
His profit needs to be
oh, so zero?
Zero, nothing, right? No profit. You don't want that in a business, but let's see when the profit would be zero. See, Dorley, this profit function is already accounting for the 420. It's already accounting for it. We don't have to say, oh, when is profit 420 to offset the 420? It's in here. You see it? It's right here. There's the minus 420. So we need to somehow figure out what X needs to be to make all of this become zero. So I just take the function and set it equal to 0 and solve for X. So I add 420 on both sides. I get 1150 X equals 420. And then I divide both sides by 1150. X equals 36.52. So approximately 36 jobs. So in a year, he has to do 36 jobs in order to just break even. And there's 52 weeks in a year, right? 52. So he's got to be doing, you know, at least a job every other week, if not more, right? One a week. Are there questions? So here's two questions I could ask you. I'm not going to write them down, but now I could ask you this. How much will he make if he does 100 jobs in a year? What would you do? If I asked you, how much is he going to make if he does 100 jobs?
Plug 100 in for X.
Yeah, plug in 100 for X, and that'll tell you how much he makes, right? And then what if I ask you this? So Joe's wondering if he should just start a different business because he needs to make money. So Joe asks himself, how many jobs do I have to do in order to make 5,000 a year off of this? What would you do if I said, you know, Joe's interested in what he needs to do to make $5,000?
Would you set the problem to equal $5,000 instead of
Exactly.
0?
You'd set the profit function equal to 5,000. And then solve for X, and that would tell you how many jobs he needs to do. It's probably a lot of jobs, but okay. It's 10:37. So let me move on. Let's look at your homework to see which problems I want you to do. This is page 89. Let's skip this first one because it talks about proportion and conversions, which we skipped that section. So please skip number 1. Page 89, skip number 1. I think this one is pretty good. Number 2, find the current minimum wage in Seattle and San Antonio. So you're gonna have to go on Google and look those up. We might get different answers because websites might give you different numbers here. So it says here, after you do that, how much would you get paid working 40 hours a day in each of these cities? So go ahead and do number 2. Number 3 for sure. George leases a machine for his business. He pays an initial fee of $1,000 and then a maintenance cost of $115 a month. Find the cost function. Okay, how much is he paid at the end of 1 year? Number 4, they give you the function, okay? They don't make you get it. They just give it to you. And then they ask you a few questions about it. Number 5, you have to come up with the function. So this is like, you know, the UTSA problem or the Bureau problem or the one we just did. So I think number 5 is good. I'd like for you to try 6. We haven't talked about it, but I'd like to see what you do. We might have questions over 6 whenever we meet again. Yeah, let's just stop at 6. So go 2 through 6 for your homework. Starting on page 89. Just do 2 through 6. And then I'll expect that you will return on Tuesday, right? With questions perhaps. And as far as our schedule goes, let's see where we are here. Today is the 23rd. So page 89, we're kind of doing this homework right now. So the next thing that we have coming up for us is supposed to be an exam, but we still have all of next week, okay? We have all of next week. So I'd like to spend Thursday reviewing for the test. Tuesday, we're gonna cover something new, all right? So we've already done this. So what I think I'd like to do is start talking about quadratics. I think we can just get a brief introduction to quadratics and put some of that information on this test. So just be aware of that. I plan on filling in this right here will be quadratics on Tuesday, and then this day will be review for the test. And then we will still have the exam on October 5th. Yeah, October 5th. Any questions? Okay. All right, everybody have a great weekend. Go hug somebody. I don't know who, just go hug someone.
Thank you.
Have a good day.